a lot given that.
Okay.
Because there's GM work in here, so
Yeah.
the pollen, we have these safety features stops pollen being transmitted from out there to the outside.
Right, okay.
And it picks all of these clothes issues. So you have to put a lab coat on.
Yeah. Should I tie my hair back as well?
No, that's true.
I'll just leave my bag out here if that's...
Yeah, that you should be fine. So we can get in without sweat.
Yeah. Sorry, I'm trying to do this one-handed.
We don't need that.
Yeah, go.
Here we go.
Thank you very much.
No worries.
Cheers.
So this is what we call the central annex. It's the main growth facility. There's a bunch of different growth chambers in here. So in these 4 rooms, these are the 4 big walk-in rooms. So this is let's check what's in there. Yeah, so you can see when they're empty, they look like this.
Yeah.
So you can see the LEDs at the top that recreate the exact wavelengths of light that you really want.
Right, yeah.
Most of the time you kind of want to set them appropriately to mimic what's outside,
Yeah.
but you can manipulate it. So
Yeah.
if you want them to fade down to sunset and sunrise, or if it's like a particular, like a shady environment, so
Yeah.
you can pick out the exact wavelengths
Right,
and the
cool. That's what I need, something
intensity
like
of
that.
light.
I just have all mine sort of set a bit more blue.
Right.
So it's I can't remember the exact reason. I'm sort of copying
Yeah,
loads of other people.
no. It's the reason we have white light is because we're trying to exactly replicate outside. We're not trying to grow particular stuff.
So you can just go through cycles of like dimming,
Yeah, so
like a
they
sunset.
simulates the sunset,
Yeah.
the sunrise at the end of the day and beginning of the day. And yeah, I mean, we could make it more blue if we wanted, if we were trying to grow like what you're trying to grow.
Yeah, if you're trying to like
Produce
stimulate a certain
stuff,
thing,
yeah, then you'll have different. But because in these, generally, the stuff we're trying to do is replicate what happens outside, but in a
Yeah.
more controlled fashion.
Right, yeah.
So we try and simulate sunlight, which
Yeah.
is why they all look white.
It's more the atmosphere and like the gas concentrations that you're changing.
Yeah, exactly. So these big chambers, you can manipulate the humidity, temperature, and lighting,
Yeah.
like to within a really precise degree.
Yeah.
In the smaller ones that we're going to look at now, you can manipulate the atmospheric composition as well. So
Right.
we tend to increase CO2 or decrease CO2
Right.
depending on what the experiment CO2. Sometimes there's one something. Oh, we saw the fun one. Okay,
Come on the
these
bad
are the
day.
smaller ones. They're really extensive.
Oh yeah. That's sweet.
And there's these guys as well. Whoa. Okay, so you can see some stuff growing in there. So these are just smaller versions of the walk-in rooms that we saw before, but these have a much greater flexibility in temperature. So
Yeah.
some of these can go down to like Arctic or subarctic temperatures.
Right.
So they say walk-in freezers.
Yeah.
Which, if you want to do like a cold shock or like, I don't know, if you're growing Arctic species or something, you might want to bring it to the temperature more. But just having a different range of sizes gives you more flexibility to what you can do, basically.
Yeah.
So these guys, these are the cool ones. These are the controlled, the really tight controlled environment growth chambers. And basically, you can control all parameters you possibly want with these. So temperature, humidity, light intensity, CO2. And there's a whole bunch of other options you can manipulate. So with CO2, it's got a detector in there that constantly monitors how much is in there.
Yeah.
And then if it drops down, it puffs a bit more in.
Yeah.
From a centralised system. If you want to reduce the CO2, you have to use the scrubber.
Yeah.
And that contains a load of soda lime, and basically it takes the CO2 out of the atmosphere and puts it back into the cabinet.
It's like similar to what some people do in the cultivating mushrooms, but like a lot more high tech.
Yeah, probably over-engineered.
Yeah.
But it's exactly the same principle, right? Because we might want to use low CO2 if we're looking over like geological timescales and stuff. We might be interested in what was pre-industrial CO2, what was the effect of that, or like pre-glacial when the CO2 was really low at like 200 parts per million. Or we might want to ramp it right up to 1500 and see, like, let's really go Paleozoic CO2. Most people tend to just double it and be like 50 years time is what we'll look at. So this one is really high. So this 1,000 parts per million.
Right.
Right, so I'm not going to open the door because I don't want to waste it.
Yeah.
But if you just sort of like look at me, see that there's the grasses that are growing on the
Oh, right.
stimulated high CO2 atmosphere, so that's rice.
Yeah, I was going to say, is that right?
Yeah.
Awesome.
It's little paddy. It's got a little
Yeah,
paddy
yeah.
building. That is. I think we can find one that's not high CO2 so we get across the road.
Yeah.
Okay, that's all dead.
Oh.
Nothing to see there. Where am I? I've got a couple of road traffic. It's based on the fungus stuff today. Postdocs in my group, and she's growing fungus with plants. She's done it very well because they're very old. She's just done an experiment. But what you can see, do you see the fungus growing around the roots?
Oh, yeah.
So the plant's trying to grow upwards, obviously it can't, but you can see like the symbiotic fungus is growing where we cultured it. It's growing into the root systems here.
Right.
So this is a high CO2 cabinet, so we're looking to see how CO2 affects that symbiosis.
Yeah.
But yeah, so that's kind of the experimental systems. That's what they look like when they're doing it. Yeah, you can see all the growth around the roots.
It's just using that as the network to follow.
Yeah, exactly. So it's taking the nutrient. I mean, this one's contaminated. It's pretty gross.
Yeah.
But, I wonder if there's better ones. I'll look at the control cabinet. So yeah, so she's doing some. She's doing like that high CO2. Yes. And this is the lower CO2 one. So we're growing some cargo here. Growing some other plants here. These are very cute. These are buttercups. So these are cultured in the sterile system. You can see all the fungus growing here.
All right.
They're very cute.
Yeah.
So what we'll do with those is we'll introduce radioisotope tracers and like look at how much nutrients going from fungus to plant.
Right.
And then we'll look at 14 CO2, we'll look at how much carbon the plant's fixing and then passing on the fungus to the media. They're not big enough yet. Well, that's a nice one. You can see all the fungal spores even. You see all
Yeah.
those fuzzy? They're spores that are being produced. Cool, huh?
Yeah.
So yeah, that's kind of the stuff that we're doing at the moment. These are nice. Look at that. Wow.
They're just little pieces of agar.
Yeah, so the culture, this particular type of fungus, you can grow it without a plant.
Right.
And what we do is basically you have plates of it, which is up in the other building.
Yeah.
But in sterile laminar flow hoods, you basically cut a square of that out, put it on the fresh media, it starts to grow, and if the plant root is there, then the root sends out chemical signals, the fungus sends out chemical signals, they recognise each other, and then they set up their partnerships. The fungus gets into the plant root and starts proliferating and living in
Right, yeah.
which is what's happening here. And ultimately what we want to do is find out what is the plant doing with that fungus.
Yeah.
And are they being beneficial to each other?
Yeah.
Is one parasitic, is the other not? Is this a pathogen? We don't know. So basically doing these bioassays to try and figure out exactly what's happening between that plant and that fungus. Pretty cool. So
Really cool.
buttercups, plantago,
Yeah.
and then we also have this plant which is metacargo. So metacargo is what we call a model plant,
Yeah.
and it's used a lot like a lab rat. And the reason for that is you've got a genome for this, and there's lots of genetic mutants that you can use to screen and try and understand what are the genetic controls on loads of different things. So we're interested in like symbiosis genes and like the toolkit the plant uses to recruit and sort of make use of its symbionts. Other people are interested in like defense genes or like I don't know, biosynthesis genes, stuff like that. But fungus that we're growing, does it use the same mechanism to colonize plant roots as other types of fungi, or is it doing something different? So we don't know yet. It's pretty exciting. Yeah, it's a really exciting project. They don't look very exciting in boxes like that, but they are really.
It trumps my experiments. So.
Oh no, that's pretty flashy. It's not very flashy. So yeah, so there's loads of different stuff going on basically. Like this is another one of the model plants. This is the Arabidopsis. So this is like the model plant. This is what everyone works on in plant science to work out anything, and then they assume that because it does it in this, it applies to all plants, and it never does. Like it can't work. Sometimes it does, but
it's just good for proving that there is an effect.
It is good, yeah. And again, the reason for that is because the genome is so well annotated. Like it's really well characterized. There's a whole world of mutants out there. So if you want to test something, you can pretty much guarantee there's an Arabidopsis mutant you could use. So you can knock out a gene you think is responsible for doing a thing, grow the plant, test it, and if it doesn't do the thing you expect, you'd be like, oh yeah, that gene is probably involved then. And there's a whole load of plant science research based around that sort of framework. So yeah, so here we've got like a whole world of growth candidates. We've got those walk-in rooms, we've got big walk-in rooms, and there's all of this again on the floor above. So it's like immense, and it has 2 full-time technicians associated with it. Kind of keep the machinery up to date and look after everything. We also have a little laboratory attached to it. Get all your things together, drying ovens, basic laboratory stuff. It's really nice because when you hire one of these cabinets, all of this is included, so you can use all your growth media.
I'd love a big box of nickel.
Right.
Like that, to be honest,
and then there's this little laboratory attached next door to it, which is where you do the clean stuff. So there's different bits of equipment here that are kind of used in different groups. So we've got a total carbon analyzer here, which basically measures the amount of carbon in a sample. Titrator. Who do we do with that? I've never used it. These are cool. This is a pressure bomb. So this is kind of yeah, I'm not going to open it. I'm scared to open it.
The name is not giving me.
No, pressure bombs are cool because you attach them to like a cylinder of gas. And then you plug a leaf in at the end, and you basically turn the gas on until the pressure reaches a point that the sap in the leaf comes out at the end of the petiole. And that then tells you what pressure it needs to be inside a plant to push water through it. And you can tell loads of different sort of like really useful information about plant physiology just based on that simple measurement. And there's so much of plant science is like that. Like, it's just little measurements you can make, and then you can infer like the whole
That's so
stuff.
cool.
It is really cool. And then this is where you do sterile work in one of these hoods. So like you probably use one when you're setting up your fungal cultures and stuff, right? So you sit at one of those, turn the UV on for a bit, and then do your thing.
I'm not quite at the point to have the setup to do that stage. I take it a little bit further ahead from that, but that's the
one day
dream. Maybe not quite that big and expensive, but
I don't think they're too bad. Like in the grand scheme of things. Like I think hoods like that are a lot cheaper than they used to be. But it's probably overkill for what you're doing. Like,
I've got my eye on some tabletop ones.
Oh really? There's one.
What do they say about a metre wide?
Getting rid of it at some point. I'll let you know. So so this is kind of how we do the growing and stuff. Any questions?
No. I feel thoroughly nourished with knowledge.
I've just talked at you.